Now moving on to our second example, we're going to be, in this video, simplifying the expression square root of 3 plus the square root of 9 quantity squared. So we're going to try using the foiling method that we did in the last example, except in this case, because we're squaring stuff, we're not going to get as much nice cancellation. However, it'll still illustrate how we combine radicals after we do the foiling process. So how do we do it? First thing we want to note is that the squared, just as with any other thing squared, it just means the thing that's being squared multiplied to itself twice, right? So this is literally just going to be square root of 3 plus square root of 7 times itself. Nothing unusual here. It's just the same old using the definition of what squared means, for lack of better terms. Okay, so we write it this way. That way it's easier to FOIL. You probably could have skipped that step if you are pretty comfortable with the foiling process, but for the sake of illustration, we did not. Foiling, we have this square root of 3. We can multiply that to both of these guys and then add them together. So we have root 3 times root 3. So we have, I'll just write that straight up. I'll simplify in the next step. And then we have square root of 3 times square root of 7. So we add those together. Square root of 3 times square root of 7. Okay, so that completes the foiling process for the first term. We do the second term now. So we have square root of 7 times square root of 3. And then we have square root of 7 times square root of 7. So we have square root of 7 times square root of 7. Sweet. All right. So now we just have a bunch of radicals that are all being multiplied together. Now we're going to try to put them all under the same roof. We cannot put the entire expression under the same roof because of these addition signs here. Radicals do not distribute over addition, as I've mentioned several times before. But they do distribute over products. So we can write these guys, since they're being multiplied, all under the same roof. So this gives us square root of 3 squared, because we're just multiplying these two things, plus square root of 3 times 7, plus square root of 7 times 3. It's the same thing as square root of 3 times 7, because you can change the order of multiplication. And square root of 7 squared. Awesome. So at this point, you can see that we have a square root and a square, and a square root and a square. So those will cancel out. This gives us 3 plus, well, this is just going to be 21 inside here, so, and in both cases we have plus root 21. And then here we have just 7 because the square root cancels the square. All right. The reason I'm not going to do the factor tree approach on this is because 3 and 7 don't break down any further. They are primes. So I can't really cancel anything out with this square root. So I'm just going to leave it as root 21 in its full combined form. And then, well, I also notice here, well, I'm trying to combine like terms. That's the goal. So I have 3 and 7. Those can be combined. I also have a root 21 and a root 21. So I have 2 of those. So I have 10 just from adding these two guys together. And since I have 2 of these root 21s, I write 2 root 21. All right, that's completely simplified. There's basically nothing else we can do right now. Sure, you could factor 2 out of each of these, but I'd say for the most part that's completely simplified. Again, simplification's in the eye of the beholder, but in my eye, this is good. Probably in your eye too, because it's done. So with that example, we are done. And yeah, if you found this video helpful, please like and subscribe. And if you want to see many more examples like this, please hit up projectgradered.com. The link is in the description. See you in the next one.